Hey everyone, so I'm going to do a video on Newton's law of cooling to clear anything up that you are confused about. Basically, Newton's law of cooling is an exponential function that describes something that is going to cool or warm in an exponential fashion. And basically your formula is this. T of t equals T of A plus T of O minus T of A e to the negative kt. Now every single thing in this formula means something. T of t is the temperature of the object after a certain amount of time, after the T value you put in. T of A is your ambient temperature, and that is the temperature of your surroundings. T naught, which is a subscript of 0, is your initial temperature of the object. So what your object is starting at. So like for a body it would be like 98.6 degrees. And then TA is repeated. E, you should know, is a constant, approximately 2.718, approximately. And K is your decay constant. And T is time. Either minutes, hours, seconds, whatever they decide. This is how you break up the formula. And basically, what you want to do is just plug into the formula. So nothing very difficult. So what I decided to do was take question 2 from your homework and go over it with you if you need a little more in-depth explanation. So what they say in this problem is they say, suppose a frozen package of hamburger meat is removed from a freezer that is at 0 degrees Fahrenheit. So your meat is already inside the freezer, and that means the meat is also at a 0 degree temperature. Then you place the meat into a refrigerator that's at 38 degrees Fahrenheit. 6 hours after being placed in the refrigerator, the temperature became this. So basically, T is your 6, and T of T is 12. That means that when you plug in 6 for T into the function, you end up getting 12 degrees as your result. And that also means that a few other things are going on here. You still need TA, which is your ambient temperature, and you need T naught, which is the temperature of the original object. The object in question is the hamburger meat. Okay, that is your object. And it's starting with a temperature of 0 degrees Fahrenheit because it came out of the freezer. And it probably is exactly the temperature as the freezer because it's been staying in there for a while. And then your ambient temperature is the temperature of the fridge, which is where you're putting into the new environment. And that is 38 degrees Fahrenheit. Okay, so this is what everything means inside the formula. And they want you to determine the decay constant. So we're basically going to plug into the formula respectively. The formula is T of T equals TA, like I said before, T naught minus TA, e to the negative kt. You know T of T is 12. TA is your ambient temperature, which is the temperature of the fridge, which is 38. T naught is the temperature of the object. Right now it's at 0 degrees Fahrenheit. Minus 38. And e to the negative k, T is 6. Okay? So right now, this is what you're focusing on. They want you to find K. So we're going to use this formula here to find K. Now this is an example of Newton's law of cooling when you're growing, and that's because you're putting a colder object, which is the meat that's frozen, into a warmer space, which is the fridge that is at 38 degrees Fahrenheit. And basically this is going to describe a relationship that is increasing. So what I'm going to do next, I'm going to solve for A. Okay, so part A asks you to determine the decay constant, which is K. And I'm going to do that by using my rules of addition and PEMDAS, reverse PEMDAS, to solve for K. So the first thing I want to do is isolate my base and my exponent, which is a regular exponential equation. Subtract 38, subtract 38. You're going to end up with 12 minus 38, which gets you negative 26, equals negative 38 e to the negative k 6. Now, negative 38, I got that because it's 0 minus 38, and that just gets you negative 38. And you want to continue to isolate the base and the exponent. The base in this situation is e, and negative k times 6 is your exponent. So I'm going to divide by negative 38. When I do that, I end up with approximately 0.68 equals e to the negative k 6. Now to solve for k, which is my variable, I'm going to need to bring it down from the exponent, and I'm going to do that by using ln, because ln and e go together. This whole entire thing will come down now, and the e will become a 1. So I really have ln of 0.68 equals negative k 6. To solve for k, I'm just going to divide by negative 6 on either side, because that'll cancel out the negative and the 6. And I'm going to get k equal to 0.063. Okay, so now this is your decay constant, and what B asks you to do is says write a function for the temperature of the meat in Fahrenheit in time hours. So all I have to do now is replace everything. It's a general function, so it's going to be T of T now. We're not going to be using the 12 anymore because the 12 is just there to help us find K. And 38 is still the ambient temperature. I'm going to put negative 38 in here because I don't really need to do 0 minus that. I'm going to take away the parentheses as well. Actually, you know what? I'll keep the parentheses. It's okay. And I'm going to also put E in here and negative 0.063 times T. I'm not putting 6 in there because 6 only helped us solve for the K value. This is my generic function. This is actually the function that you can graph to describe the relationship of the heat warming up to the fridge's temperature. And when you graph this function, I'm not going to do part D right now, but when you graph this function, you're going to see it basically approach the asymptote. And the asymptote in this case is a 38. Okay, so I'm going to put 40 up here. Your graph should look like this. And just change your window so that the Y max is at 40. And I would scale the Y with like 10, maybe to see it nicer. And you'll basically see that it's not going to hit the asymptote at 38. That's all. Okay, so you can see that it's growing exponentially. The next part asks how long will it take for the meat to thaw, which means it's going to reach a temperature above 32 degrees Fahrenheit. Basically, that means that you're going to take your function that you have, T of T 38 plus 0 minus 38, which is really negative 38. I don't know why I'm rewriting it like that. So negative 38 e to the negative 0.063 t. And they want you to know how long it's going to take. So how long in time? And this time is in hours. So how many hours? And basically you're going to do 32 degrees, set this equal to that. You're looking for the t value that was put in here to get you 32 degrees or above. You could also set this formula less than to this if you wanted to give it an inequality value, but I'm just going to leave it the way it is. Okay, now to solve this like a normal thing, isolate the base and the exponent. 32 minus 38 is going to get you a negative 6. Negative 38 e to the negative 0.063 t. Divide by negative 38. When you divide by that, you are going to get approximately 0.1579 equals e to the negative 0.063 t. Again, you're going to utilize ln so you can bring down the exponent because that exponent has your variable. You want to bring this whole thing down. This guy will cancel to 1, and you basically have ln of 0.1579 equal to negative 0.063 t. Okay, to solve for t, you're going to divide by negative 0.063. That'll get you t to be approximately 29.298. Now, if you were doing to the nearest hour, you would do 30. Okay, so basically it's going to take 30 hours for this piece of meat to reach the fridge's temperature or get close to, oh, what are we doing? Close to the meat thawing, okay? So I hope this video helped. We have one more part, I think, actually. Yep, part E. And what part E asks is to find the rate of change. Okay, so they're looking for the percent rate of change. Now, your formula that you have for this specific scenario is T of T equals 38 plus negative 38 e to the negative 0.063 t. Now, the rate of change all has to do with your decay constant and the base. And in that case, that is this right here. Okay? That is technically 1 plus r. Okay? And if you think about y equals ab to the x, it kind of symbolizes the same format, but that is 1 plus r. And basically, you can find your rate if you set this equal to 1 plus r. And again, you're trying to find the rate of change of the difference between the refrigerator and the meat. Because remember, your object's temperature is going to change in respect to the temperature of the ambient temperature. And all I'm going to do is do e to the negative 0.063. That's going to get me 0.9389. Subtract 1, which means my rate is negative 0.0611, which means that I have a decrease of 6.11% per hour. So that means that your percent rate of change between the difference of the temperature of the meat and the temperature of the refrigerator is in respect to decreasing by 6.11% per hour. Okay? So I hope this video helped, and I will see you guys tomorrow.